identical for this curve. Next point, we have to check the geometrical properties of the curve is axis intersection. In this case, we have to check where the curve meets the coordinate axis. If we put y is equal to 0 in the equation of the curve and find x, by this method we can find the point of intersection of the curve with the coordinate axis. And we have to also check whether the curve meets the line y is equal to plus or minus x. If y is equal to plus or minus x is the line of symmetry, that is, if the curve symmetric about this line y is equal to plus or minus x, then we have to check the point of intersection of the curve with this line. So we have to find the point of intersection of the curve with the line y is equal to plus or minus x. Then again we have to check whether these points are ordinary points or multiple points. Next property is we have to check for the geometrical property of the curve is asymptote. First of all, I explain you what is the meaning of asymptote. Simpler meaning of asymptote is the tangent to the curve at infinity. Tangent to the curve at infinity. Simple example or best example of the asymptote is railway track, which are seems to be meet infinity but they never meet. So a straight line is called a asymptote to the curve if a point on the curve tends to infinity and perpendicular distance of the curve of the point from the straight line tends to 0, then we can say that the given straight line is an asymptote to the given curve. So there are some methods to find the asymptote parallel to coordinate axis and asymptote oblique. To find the asymptote parallel to x-axis, equate to 0 the coefficient of highest power of x present in the given equation and find the linear factor. Equate each linear factor to 0, which give you the asymptote parallel to x-axis. To find asymptote parallel to y-axis, by the same way, equate to 0 the coefficient of highest power of y present in the equation, resolve it into the linear factor and equate it to 0 each linear factor, which will give you asymptote parallel to y-axis. Now we have to check whether the curve has any oblique asymptote or not. For this, to find the, you know that the oblique equation of the oblique asymptote is of the type y is equal to mx plus c, where m is the slope of the asymptote and c is the y-intercept. So to find the oblique asymptote, we have to determine the slope m and y-intercept c. To find the oblique asymptotes, first of all, we have to separate higher degree terms in the equation of the curve. Say it phi n xy, where phi n xy is the polynomial of highest degree n in x and y. Put x equal to 1 and y equal to m in the polynomial phi n xy. Equate it to 0, that is phi n xy or phi n m equal to 0. Solving this equation will give you the slope of the tangent. Now finding the slope of the tangent, again put x equal to 1 and y equal to m in the next lower degree terms of the given equation and then find phi n minus 1 of m and similarly find phi n minus 2 of m. By solving the equation, phi n of m gives the slope of the tangent. Then for the real distinct values of m, we have to find c from the equation. You can see here c into phi n of m plus phi n minus 1 of m equal to 0, that is c is equal to minus phi n minus 1 of m divided by phi dash n of m, which will give you the y-intercept c. Putting the values of m and c in the equation y is equal to mx plus c gives the oblique asymptote. Thus, we have to find all the asymptote parallel to coordinate axis or oblique if the curve has. Then next property which we have to check, geometrical properties of the curve which we'll have to check is the region. Region, that means the curve lie in what region, that is whole curve in which region lie, or we can also say that in which region the curve does not lie. This can be done by the solving equation for one variable to y. Thus we have to check, we have to determine the region of the curve, in which region curve exists and in which region curve does not exist. So by considering this property, we will trace some curve. So considering the above geometrical properties of the curve, we can trace the following curve. First curve is given here, y square into x square plus a square equals x square into a square minus x square. I will take this example, I will explain you this example. So write down. Equation of the curve is curve is given as y square into x square plus a square equals x square into a square minus x square, where a is greater than 0. First property we have to check, that symmetry of the curve. You can see here that this equation contains even powers of both x and y. So it is symmetrical about both the axes. Here power of y is 2, power of x is 2, also power of x is 4. Both the variable x and y contains even powers of y. So the curve is symmetrical about both the axes. Also it is symmetrical about origin, because a curve which is symmetrical about both the axes, which is also symmetrical about origin. So hence it is symmetrical about origin also. Second property we have to check, that origin and tangent at origin. From the equation you can see here that equation does not contains any constant term, so it will pass through the origin. So the curve pass through the origin. Curve passes through the origin since it does not contain any constant term. Now we have to check the nature of origin, whether it is an ordinary point or a multiple point. This can be done by equating to 0 the lowest degree term by Newton's method. You can see here in the equation of the curve, lowest degree terms are y square into a square equals x square into a square, equating to 0. So nature of the origin, equating to 0 the lowest degree term, gives us what? Here you can see that gives us y square into a square minus x square into x square equals 0. A is greater than 0. That is a square into y square minus x square equals 0. This will give you y square is equal to y square minus x square is equal to 0, since a is greater than 0. Hence this will give you y is equal to plus or minus x. Thus the curve passed through the origin, and nature of the origin, here we have find two tangent y is equal to plus or minus x which pass through the origin. These two tangents are real and distinct, so origin will be a curve. These two tangents are real and distinct, hence and so we can say that origin will be a node. Thus we have determined nature of the origin. Now we will check axis intersection, whether the curve intersect the given equation. So equation is y square into axis intersection. Next property is axis intersection. Put x y is equal to 0 in the given equation. Gives what equation is here? Y square into x square plus x square. If we put y is equal to 0, this will give you x square into a square minus x square is equal to 0. That is x is equal to 0 and x is equal to plus or minus a. If x equal to 0, then y will be, if you put x equal to 0 in this equation, y will be 0, so implies that y is equal to 0. Second, if x is equal to a, if we put x equal to a in this equation, again gives y is equal to 0, then this implies that y is equal to 0. If we put x is equal to minus a in the given equation, y square into x square plus a square equal to x square into a square minus x square. If we put x equal to minus a, again this will give you y is equal to 0. Hence we can say that hence the curve meets x axis at the point zero zero, that is origin. Next point is a0, or third point is minus a0. Thus 0 0, a0, minus a0 are the points of intersection of the curve with the coordinate axis, that is x axis. Now again we have to check the nature of this point. Nature of the point we have to check of the points 0 0, 0 0, a0 and minus a0. First point we have already checked, it is a node. We have checked that. origin 0, 0 is a node. So we have to remains only check the nature of this next 2 points, A0 and minus A0. So we find the nature of the point A0. To determine the nature of any point, we have to find first of all tangent at that point. By Newton's method, we can find tangent at origin. Here we have to shift this, we have to shift the origin at this point. So to find the tangent at the point, to find tangent at the point A0, which is not origin, so we will shift the origin at this point. To find tangent at the point A0, we should shift origin to the point A0 by putting x equal to capital X plus A in the equation of the curve. Equation of the curve is y square into x square plus a square equals x square into a square minus x square, where a is greater than 0. Now we replace x by x plus capital X plus a. So here will be y square into x is replaced by capital X plus a. So capital X plus a square plus a square equals again x is capital X plus a square into a square minus capital X plus a whole square. Simplifying this, which will give us y square into x square plus 2ax plus a square plus 2a square equals x plus a square again gives x square plus 2ax plus a square and into a square minus x square minus 2ax